In this lesson, we simplified radicals, we simplified square roots, cube roots, we simplified expressions that contained radicals. So a throwback to Algebra 1 here, write each expression in simplest radical form. I want to simplify all of these square roots. So how do I simplify the square root of 125? Well, I need to think of what's the biggest perfect square that goes into 125. And this is where knowing your perfect squares well is important, because you should say, wait a minute, that's the square root of 25 times the square root of 5. Because 25 is a perfect square, so I can write that as 5 radical 5. Those two expressions are equivalent. B is negative 4 plus the square root of 24 over 2. So let's tackle the square root of 24 over here. How can I tear apart radical 24 using a perfect square? Well, 16, no. 9, no. 4, though, this is radical 4 works. This is radical 4 and radical 6. So that's 2 radical 6. So I have negative 4 plus 2 radical 6. Instead of calling it the square root of 24, I'm going to call it 2 radical 6 divided by 2. Well, I'm dividing each of these terms by 2, so that gives me negative 2 plus radical 6. That's written in simplest radical form. I can't divide by 4 yet because I need to simplify the square root of 128. So how can I rewrite this? Well, what are my perfect squares smaller than that? 121, no. 100, no. 81, no. 64? Yeah, this is 64 times 2. So this is 8 radical 2. So this is really 8 radical 2 divided by 4. Well, 8 divided by 4 is 2. 2 radical 2 is what that expression is equivalent to. Write each expression in simplest radical form. So we're taking roots here of 32. So if I take the square root of 32, I need to figure out what's the biggest perfect square that goes into 32. Well, wait a minute, that's the square root of 16 and 2. So that's 4 radical 2. Now I'm doing the cube root of 32. I don't want the biggest perfect square, I want the biggest perfect cube. 1, 8, 27, 60. So clearly 8. I'm going to split this up as the cube root of 8 and the cube root of 4. Well, the cube root of 8 is 2, so this is 2. The cube root of 8 is 2 because 2 times 2 times 2. So 2 cube roots of 4. Now I'm taking the fourth root of 32. Well, maybe it'd be good to know what are our perfect fourths, but that's what we have a calculator for. So what times itself, and I have 4 of them, so 1 times 1 times 1 times 1 gives you 1. 2 times 2 times 2 times 2 is 16. So if I do the fourth root of 16 and the fourth root of 2, well, the fourth root of 16 is 2, because that's 2 times 2 times 2 times 2 gives me 16. So the fourth root of 16 is 2. Fourth roots of 2 is my final answer. And finally, the fifth root of 32. Well, what times itself 5 times gives me 32? What's the biggest perfect fifth that's a factor of that? Well, what's 2 times 2 times 2 times 2 times 2? Well, that's 16 times 2 is 32, so this is just equivalent to 2. Number 3, express each of the following in the simplest radical form. Assume that all variables are positive. So I've got a square root here, which really has a little index of 2, but we don't write that 2 on the square root, but it's there. I need the square root of 36, the square root of x to the 5th, the square root of y squared, and the square root of z. Well, the square root of 36 is 6. The square root of x to the 5th. Well, maybe it's helpful to write x to the 5th as x squared times x squared times x. I have to the first, because I have 5 x's there. So if I take the square root of each of those, I can take out 2 groups of 2. So one group of x squared becomes an x. The other group of x squared becomes another x, so I get an x squared outside the radical x. The square root of y squared is y. And radical z, there's nothing I can really do there, so I'm taking out groups of 2. I'm taking out groups of 2 because I'm dealing with that square root. So my final answer is 6x squared y square roots of xz. I've got the cube root of a to the fourth, b to the ninth, over 64. Well, this is really the cube root of the top over the cube root of the bottom. Well, I'm taking out, because I'm dealing with a cube root here, I'm taking out groups of 3. So if I take out 3 a's, I get an a outside the cube root because I got rid of 3 of them, and I'm left with 1 a. The cube root of 9, well, I can take out groups of 3 there. I can take out one group of 3 is b to the third, another group of 3 is b squared, so I get b to the third because I can take out 3 over 4. So my final answer is a, b cubed, cube root of a over 4. We're taking out whatever that index is. We're taking out groups of the index. So I have the cube root of 16, x to the 7th, y to the 8th. It's probably actually easier to deal with the variables first. I can, well, 7, how many groups of 3 can I get from that? I can get 2 groups of 3, and I'm left with 1 inside there. Y I can take out, y to the 8th, I can still take out 2 groups of y, but I'm left with 2 inside the radical. So how do I deal with this radical 16 here? How do I deal with this radical 16? Not just the square root of 16, the cube root of 16. But what's the biggest perfect cube that goes into 16? Think of your perfect cubes, 1, 8, 27. It's got to be 8. The cube root of 8 times the cube root of 2. So 2 cube roots of 2. So my final answer is outside the cube root, sorry, there's a cube root sign here that I forgot. 2x squared, y squared, cube roots of what's inside 2xy squared. That's how we simplify these radical expressions.